Okay, so in the last video, we talked about the pH problem solving horseshoe, which you guys were supposed to memorize. At least that was the recommendation. So today, we're going to be using this horseshoe to solve these problems, and hopefully that'll give you guys a better understanding of the horseshoe and what kind of questions you guys will be asked, and also, of course, how to solve these questions. So the first question is determine the pH of a 0.0034 molar HNO3 solution. So from your guys' data sheets, or if you guys are using memorizing this strong acid, you'll know that this is a strong acid, meaning it dissociates 100%. So what we can do using the horseshoe then is we can say that a concentration of the strong acid, which we're given, is equal to the concentration of hydrogen ion or hydronium ion, and we can go to pH simply by taking the negative log going downwards. So let's go ahead and do that. So pH equals the negative log of the hydrogen ion concentration, which is the same as the acid concentration since it's a strong acid, and that's going to equal the negative log of 0.0034, and that equals 2.47. Now, considering it was a strong acid, this makes sense since it's a fair bit away from neutral pH of 7 in the acidic direction. Remember that acids are less than 7 and bases are greater than 7 when it comes to pH. The next question here is determine the pH of a 4.3 times 10 to the negative 4 molar sodium hydroxide solution. Now, sodium hydroxide, since it contains hydroxide, we can say is this a strong base, and in fact it is a strong base. You can see it's on the bottom of your data table, or you would know that if you had memorized them. And so since it's a strong base, using the horseshoe, we first have to find pOH and then pH. So it's a two-step problem. And teachers often like to use these kinds of questions to see whether students truly know what they're doing, or to test multiple concepts or stuff like that. And so this is probably some kind of questions that you'll see, this one and the next one. So getting into this one here, first we find the first we'll find the pOH and then we'll find the pH. So step 1, find the pH or the pOH using the concentration of the strong base, which is the negative log of 4.3 times 10 to the negative 4, which equals 3.37. Now you might be thinking, why is that such a low number? Well, because pOH and pH scales are backwards. So where acids would be on the pH scale, bases replace them. And where bases are on the pH scale, acids go there. So it's backwards, and so this is a reasonable answer to get for the pOH of a strong base. Next, we can find the pH using our horseshoe, 14 minus pOH. So all of these questions can be solved using the horseshoe. So right now I'm just going from pOH to pH, and so 14 minus 3.37, which equals 10.63. So that's good because this is in fact a base, and bases are greater than 7. and this one here is a fair bit greater than 7. The last question is a multi-part question again. It's determine the concentration of hydroxide ions in a 0.027 molar HCl solution. So let's go ahead and do that. So HCl is a strong acid, so we can go ahead and say that the pH equals the negative log of hydrogen ion concentration, which is equal to negative log of 0.027, which is equal to 1.569. Then we go to pOH, which we said is equal to 14 minus the pH, and that equals 14 minus 1.569, and that equals
clear, 1, 4, minus 1.569 equals 12.431.
12.431. And lastly, pOH to hydroxide ion concentration, we're going to take the antilog, or 10 to the negative of the pOH, which is equal to 10 to the power of negative 12.431, which is equal to
clear.
Let's go ahead and figure that out. Ten to the power of negative 12.431.
One, 0. To the power of left paren negate equals minus 10. Clear. 1, 0. Second function, x root of y. First function. Clear. 1, 0, 6. Delete. To the power of left paren 1, 2, decimal 4, 3, 1. Negate equals minus 12.431. Right paren equals right paren. Clear. 1, 0. Second function. First function. To the power of 1, 2, 2. Clear. 1, 0. To the power of 1, 2. Decimal 4, 3, 1. Equals right paren. Clear.
Sorry guys, I don't have a calculator here, so I'm trying to do this. See if this works. 10. .71 times 10 to negative 13 molar. Awesome, there you go.